All right, so let's talk about ADH. Okay. So ADH is what? What does it stand for?
Anti-Diuretic Hormone.
Good. So we have our anterior and posterior pituitary. We have our kidney again. Bigger this time. Don't know why. Just is. And we have our blood vessels.
An enlarged kidney.
It's not at all accurate.
You know what, the kidneys could also double for fetuses, so that's great. Like a little teeny tiny little, you just draw some eyes on it, and it's a little being.
Particularly that one when I drew a little oblong, worked really good for the fetus. So, okay, so how does this work? Oh, I should ask, what type of things trigger the renin-angiotensin-aldosterone mechanism? We talked about low blood pressure, right? And that's it, because the kidneys don't have chemoreceptors for this. They just detect drop in blood pressure. ADH, on the other hand, we have two things. We have the baroreceptors, right? Same baroreceptors that we used before to sense the pressure. So those will stimulate the hypothalamus, saying our pressure is too low, right? This one only works to increase blood pressure. Okay, and then we have osmoreceptors. What's an osmoreceptor?
Detects the change in osmosis.
Good. Yeah, so it measures how concentrated our blood is with solutes. So we don't want to be too concentrated, we don't want to be under-concentrated either. So this mechanism only reacts to over-concentration. We have too much solute in our blood, so basically we're dehydrated. Right? We're dehydrated, that means we don't have enough water. We probably have plenty of solutes, but we don't have enough water. So, anti-diuretic hormone, what is that going to do? Just by the name, what does that tell you?
It's gonna release. It's gonna retain water.
Going to retain water. So it's an anti-diuretic, anti-urine. We're going to decrease urine output. So that water that we would have put into the urine, we're going to keep it and put it back into our blood instead. So we're going to increase our blood volume.
Sounds weird.
Sounds
like
weird thinking you have
peeing in normal.
urine particles in your blood, but we filtered everything out. We're just putting the water back. Okay. All the waste we're still getting rid of.
Take a leak.
Which is why urine, that's when, you go to scout camp, whatever, they're like, why don't you pee in clear? Drinking so much water that your urine's clear, right? Because that means there's not as many solutes in it. You have plenty of water, so you can waste some. When your urine's super concentrated, really dark, you're dehydrated. You don't have enough water. So your kidneys have to work extra hard to pull that extra water out and keep it in your system. So ADH responds to low blood pressure through baroreceptors and high concentration through osmoreceptors. So, pretty straightforward actually. It tells the kidneys increase water reabsorption, increase sodium reabsorption. Tells the blood vessels constrict. End result, blood pressure goes up. Really, same concept as aldosterone, right? A lot more straightforward, a lot simpler. So this one takes less time. Still considered long-term. Takes less time to initiate, but it doesn't last as long as the renin-angiotensin-aldosterone mechanism either. So, aldosterone's lipid soluble. We talked about how that worked. ADH is water soluble, so how does ADH work?
Has to bind onto a receptor on the top of the membrane, send a second messenger through, so that it can go to the DNA part and either replicate it or change what it needs to.
Yeah, so we want to reabsorb more sodium, right? So, and we won't go as deep with this until we get to the kidneys, but the idea is we're going to open more sodium channels, whether it's through a second messenger or just a deep protein system. And right off the bat, I don't remember, I have to look. So that's partly why we're gonna go over it later. But the idea is, we're gonna open sodium channels, and we're gonna reabsorb more sodium. So when we get to the kidneys, we'll go deeper with it, but. That makes sense? Good deal.